Welcome to Section 3 of the Value Stream Mapping Program by Advance Innovation Group. In this section, we'll move beyond mapping components and focus on analyzing the current state map, identifying bottlenecks, wastes, and opportunities for improvement. This is where we start converting insights from the map into actionable plans. In this section, we'll learn how to create the current state map step by step. The goal is to build a data-rich, as is view of the process. Our deliverables include the process and information flow, data boxes, and the lead time ladder. By the end, we'll clearly see bottlenecks, wastes, and quick wins, the foundation for future improvements. Before creating the current state map, some pre-work and chartering are essential. First, define the scope, usually door-to-door, from the first customer signal to product receipt. Second, identify the product family using PQPR, focusing on those with at least 80% common routing. Third, form a cross-functional team with the value stream owner, process representatives, quality, and IT. Finally, plan logistics, schedule Gemba visits, arrange data access, and ensure safety and IT permissions are in place. When collecting Gemba data, focus on capturing facts directly from the workplace. At each step, record details like cycle time, process time, changeover, uptime, first pass yield, batch size, VIP, queue time, number of operators, and defect rate. For an end-to-end view, include lead time, handoffs, rework loops, and information triggers. In service environments, capture timestamps for when tasks are created, triaged, assigned, and completed. These help map flow delays and identify improvement areas. This slide shows the basic skeleton of a value stream map layout. The top lane represents the information flow, including orders, schedules, approvals, and alerts. The middle lane contains the process flow, showing process boxes, data boxes, and VIP triangles. Finally, the bottom lane is the lead time ladder, where we compare value-added and non-value-added time to understand total process efficiency. Step 1 in building a value stream map is to place the customer and supplier. On the right side, position the customer, capturing details like demand, talk time, and delivery frequency. On the left side, place the supplier, noting information such as replenishment cycles, minimum order quantities, and lead times. Also, record any SLAs, electronic data interfaces, or portal loss connections that define communication between the supplier, process, and customer. Step 2 is to sequence the major process blocks. Start by drawing 5 to 10 macro steps. These represent key process stages, and you can merge smaller micro steps into them. Keep the logical and physical order of the process and make sure each step is clearly named. Also, leave space below each process box for adding data boxes later, where you'll capture performance details like cycle time, uptime, and first pass yield. Step 3 is to add the material or service flow and VIP to the map. Use solid arrows to show push flow and open or dashed arrows for pull systems like Kanban or FIFO. Mark VIP triangles between steps, showing either quantity or days of inventory. If material or information moves over long distances, note the transfer or transport times. These delays often reveal hidden waste in the process. Step 4 is to fill the data boxes accurately. Include all key metrics like cycle time average and P95, process time, changeover time, uptime, first pass yield, batch size, VIP, and queue time. In service processes, separate touch time active work from system wait time for better visibility. And always use verified logs or actual data. Avoid assumptions or gut feeling, as accuracy here drives the credibility of the value stream map. Step 5 is to draw the information flow, which sits in the top lane of your VSM. Include all control and communication elements like master production schedule MPS, Heijunka Kanban or eKanban signals, emails, and line-of-sight loss rules. Define the frequency of communication, whether it's weekly, daily, or hourly, and specify who signals whom in the process. Finally, add approvals, escalations, SLA alerts, and dashboards to show how information supports decision-making and flow control. Step 6 is to build the lead time ladder, which helps visualize how long your process actually takes. Start by calculating value-added time VA as the sum of process times and non-value-added time NVA as the total of queues, transfers, and rework waits. Then, calculate lead time LT as VA plus NVA and determine the percentage of VA using VA divided by LT. Plot these times visually beneath the process map. Show each segment's duration and the total at the far right. This gives a clear picture of where time is spent and where delays occur. This slide shows a numerical walkthrough of a manufacturing process using real VSM data. Here, the demand is 900 units per day, giving a takt time of 30 seconds. That's how fast each product should move to meet customer demand. The paint process has a changeover time of 60 minutes with a batch size of 50. Before assembly, there's a VIP of 1,200 pieces, representing 2.5 days of inventory. In assembly, the cycle time is 38 seconds, and the 95th percentile P95 goes up to 40 seconds, making it a bottleneck compared to the takt time. This helps identify where the flow breaks and improvement is needed. This slide shows a service process walkthrough using actual performance numbers. In the help desk process, the takt time is 140 seconds. That's how often a new request should be handled. The actual touch time is around 180 seconds, but there's a queue delay of 30 minutes, showing waiting as waste. For the loan process, the total lead time is about 2.1 days, with a KYC first pass yield of 89%, meaning frequent rework loops. Finally, underwriting happens in a daily batch at 4 p.m., causing an average wait time of 1.5 days before processing starts. Together, these figures show clear opportunities for automation, parallel processing, or queue management improvements. This slide introduces the idea of variability and P95 thinking. Instead of looking only at average cycle time, we also capture the P95 cycle time. This shows how bad things can get on the slowest 5% of cases. We also check for uptime dips and arrival variability, like spikes during certain hours or seasonal surges. Finally, remember the queuing rule. When a process is highly utilized and also variable, it leads to long waiting times. This thinking helps design more stable and predictable flow in both manufacturing and services. This slide focuses on identifying rework loops and uncovering what we call hidden factories, places where extra, unplanned work happens. We first find the percentage of rework and locate where items re-enter the process. For example, in services, missing documents can send a case back into the KYC loop, while in manufacturing, a failed test may send a product to the repair bay. We then measure how long these loops take and classify the types of defects. Quantifying rework is key because hidden factories consume resources but add no customer value. This slide highlights common information traps that disrupt smooth process flow. Often, organizations have multiple priority rules and conflicting schedules, which confuse teams and cause delays. Next, manual approvals and email chains become black holes or requests go in, but responses take forever. Finally, the lack of auto-validation or clear triage rules means items wait unnecessarily for someone to decide their next step. By mapping these traps, we can spot where information flow breaks and design automation or standardization to fix it. This slide emphasizes the importance of maintaining visual and data standards in value stream mapping. Always use standard icons and consistent units so that anyone can easily read and compare maps. Clearly label your data sources, whether the information came from logs, stopwatch studies, or reports, to ensure traceability. Finally, always date stamp your maps and maintain version control so future teams know which version reflects the current state. This helps sustain credibility, accuracy, and consistency in improvement projects. When doing Gemba walks or process observations, safety and compliance come first. Always follow site-specific rules, wear PPE, respect no photography zones, and protect any personal or health information PII. Be mindful of the observer effect, avoid disrupting the team. Blend in quietly and note timings silently. And most importantly, know the escalation path in case you spot an unsafe fact or condition. Remember, improvement never comes at the cost of safety. This mini workshop helps participants apply what they've learned by building the current state value stream map. Each team will use dataset M01 or S01 provided earlier. They'll map the process flow, information flow, fill the data boxes, and create the lead time ladder. By the end, teams should identify 3 to 5 key wastes and prepare a short bottleneck statement that summarizes where delays or inefficiencies exist. This hands-on exercise connects learning to real analysis and discussion. These are the most common mistakes teams make during value stream mapping. First, don't map the to-be process. Start with the as-is reality. Second, avoid guessing numbers. Always use verified data like P95 cycle time and uptime. Third, don't mix product or service families and never skip the information flow. Finally, outcapture rework loops and queue times. Missing these leads to an incomplete map. Remember, accuracy and honesty make your current state map valuable. This is your final checklist for the current state map before sign-off. Ensure the customer and supplier are defined and talk time is calculated. All process data boxes must be filled. Include cycle time, changeover, uptime, FPY, VIP, and queue. Verify that information flows and approvals are mapped. The lead time ladder and percent value added must be computed. Finally, identify the bottleneck, list the top wastes, and mark the date and version on your map. Only after this can you move forward to the future state design. Congratulations, you've completed the current state mapping. By now, you have your as-is value stream map, along with the data boxes, lead time ladder, and bottleneck analysis. In the next section, we'll move on to designing the future state map, focusing on flow, pull systems, and leveling. Before that, take a moment to list your constraints, note a few quick wins, and identify any data gaps you still need to close. This preparation ensures a smooth transition into the improvement phase.